Hello, folks. We'll get going in about 4 or 5 minutes. All right. Welcome, folks. We're going to get started. Get the upside down view going here. All right. There we go. So, welcome everybody to the 21st day of remote learning. Today's joke is, what does a vegetarian zombie eat? Grains. Hope you enjoyed that one. Happy Wednesday. Simplify that like button to show your support. The YouTuber on today's lesson is Jeremy Fielding. He takes apart things that people have thrown out and makes them into tools and other useful items. There are quite a few YouTubers who do this kind of recycling, do it yourself stuff. But I find that he makes objects that are more useful than what a lot of the other ones make. And I really like his channel. So the video linked in the lesson shows him taking apart an old washing machine and salvaging it for parts and then making some different projects out of them. So I hope you'll enjoy. Today's lesson, we are going to continue with our review, and we're going to look at some of the trickier things that can be done with the techniques that we've learned. And you'll start to see this stuff pretty commonly as you move into grade 10. So I wanted to make sure that you had some experiences with it. Normally, this is the kind of thing that we do in class, sort of towards the end of learning a topic. And with the remote learning, we've been mostly doing the basic level ideas for each of the topics. So I wanted to do a few of these harder questions so that when you see them in grade 10, you're not lost and worried about them, but you have some memory of how it works and can figure things out with a little help from your teacher. So that is our goal for today. Let's jump right in. All right. So in the classroom is the day 21 examples document. Just like last week, or just like Monday, pardon me, the homework is to complete the EQAO quiz. And there's a few questions in there that are pretty tricky. So I want to go over some similar ones here as we work together. And my apologies, I'm going to be jumping back and forth between the chat and the examples page. So if I miss something in the chat, give me a few extra seconds and I should be able to get back there. So question one, this is an example question for a skill that we haven't learned. And I want to show you how to solve this question without learning the skill that's needed to solve it. I know that sounds really weird, but with multiple choice questions, it's often true that even if you don't know how to solve the question, you can figure out how to check an answer. And since there's only 4 possible answers because it's multiple choice, or maybe 5, if you check those answers, then you can quickly see which one is correct, even though you don't know how to solve the question. So that's a little tip that's useful in any course where you might see a multiple choice question. And we'll take a look at this one. So it's telling us that there's a rectangular garden. So we'll just draw a little picture of that here so that you can see what's going on. And it's fenced in, and we're using 36 meters of fencing. So that's the total. So that means if you start here and you measure along this side and this side and this side and this side, that total distance will be 36 meters. So in other words, the perimeter of the rectangle is 36 meters. Then we're asked which of the following lengths for the garden gives the maximum area. So if we do this for the length and this for the width, they're asking if the length is 2 meters, or if it's 6 meters, or if it's 9 meters, or if it's 12 meters, which one is going to give us the maximum area? So there actually is a very nice technique for maximizing the area of a rectangle. And normally we would take the time to do that in grade 9. And I'll give you I'll give you the whole story very quickly. But if you're trying to maximize the area of a rectangle for a specific perimeter, so in this case, 36 meters, the biggest area rectangle is always going to be a square as long as you're building all 4 sides of it. So that might be enough for you to figure this out. But let's say we don't know that rule. How are we going to do this? Well, we could look first of all at 2 meters. If we have a garden whose length is 2 meters, well, that means this side is also 2 meters. We have 36 meters of fencing. 4 of it has been used up, so there's 32 meters left. So 36 minus 2 equals 32. And we know that there's 2 parts to that that are equal length, both widths here. So if we take that, we divide by 2, that will get us to 16 meters, which is going to be the measurement for the widths. So this is the lengths of all the different sides if the garden has a length of 2 meters. And we can figure out the area for this garden. The area is 2 times 16, length times width, or 32 meters squared. So that is A. For B, we have 6 meters for the length, and we need to figure out the width. So we can do 36 meters, take away 6, take away 6. And when we look at that, divide it by 2, 36 minus 6 is 30, minus 6 is 24. 24 divided by 2 is 12. So that means this side is 12 and this side is 12. And then we can figure out the area for that one. 6 times 12 is 72. So this rectangle is going to have an area of 72 meters squared. So you can see we get a lot more garden area with the same perimeter. Both of these rectangles have a perimeter of 36, but this one gives us more than twice as much area as that one. Okay, so we can keep working through here. C, same idea, except that now we know that it's 9 meters on both sides. 36 minus 9 gives us what's left, and we have to divide it by 2 because there's 2 parts. 36 minus 9 is 18, divided by 2 is 9. So that means these remaining ones have to be 9 meters. And if we calculate the area for this rectangle, we get 9 times 9 equals 81 meters squared. And then for our last one here, we have 12 meters as the length. 36, take away both of those lengths, gives us what's left. And if we divide it by 2, because there's 2 sides, we'll get that. So 36 minus 12 is 12. Divided by 2 is 6. So we'd get 6 by 12. And that's not really surprising because that's what we had here when we started with 6. And that tells us that our area is 6 times 12, again, 72 meters squared. So here we can see that the one that maximizes the area is when the length is 9 meters. We get the highest area, 81 meters squared. It's higher than any of the others. And in fact, if you remember what I was saying about squares, you can see that this rectangle is a square, all 4 sides the same length, and it does give us the highest area. So we didn't know that idea about squares. We can still go through and just test out each of the 4 different answers, check them out. Okay, if we know the length, we can figure out what the width has to be. And if we know the length and the width, we can calculate the area. Once we do that for all the answers, we can tell that C is correct. 9 meters length gives us an area of 81 meters squared, which is the maximum. All right. So give me a 1 in chat if that's making sense. And if you have a question, now would be a great time to ask it. Thank you, Alan. Thank you, Adam. Thank you, Owen. Thank you, Jordan. All right, so that's question 1. Let's take a look at our next one. And again, if you do have things that you want to ask, feel free to put them in the chat. I'll try to keep an eye on it and catch anything that you put in there. So there we go. Next one up, we're looking at the second question. The second and the third question are both questions that have a little bit more complexity to them than the usual ones, but I think will be good. So here we have a circle and a rectangle. Perimeter of the circle and the perimeter of the rectangle are the same. Oops, sorry, that should be PR down there. All right, they have the same perimeter. So the perimeters of both of them are equal. The diameter of the circle is x plus 1. And the side lengths of the rectangle are 5 and x minus 1. What is the value of x? And I realize my grammar here is not very good, so I'm going to fix that up. For those of you looking in the document. So we want to find x. We know that the two perimeters are the same. Well, first thing we're going to do is we're going to set up the perimeter of the circle using our formula. So perimeter for a circle is pi times the diameter. In this case, the diameter is x plus 1. And if you look at what I did here, we've got a bit of a problem. I've left something out. The formula is pi times the entire diameter. The way it's written here, we do pi times x, but we're not doing pi times 1. So we need to actually put this in brackets so that it's pi times the whole diameter. And that will give us the perimeter of the circle. For the perimeter of the rectangle, well, it's length times width. And in this case, that is 5 times x minus 1. And again, I have to use brackets here because I want the 5 to multiply the whole x minus 1, not just the x. So that sets us up with two expressions, one for the perimeter of the circle, one for the perimeter of the rectangle. We know those two are equal, so that means that pi times x plus 1 equals 5 times x minus 1. Perimeter of the circle there equals perimeter of the rectangle, which is 5 times x minus 1. So now we can do our distributivity. Pi times x, pi times 1. And over here, 5 times x, 5 times negative 1. And now we just need to solve this and find the value of x. So it's going to be a little bit of a trickier one. So we'll have I think I want to keep the x's on the right side. So I'll do pi x plus pi minus pi equals 5x minus 5 minus pi. And then, oh, sorry, I'll move the x's to the left side. So then we'll get pi x minus 5x equals 5x minus 5 minus pi, minus 5x. So here, pi minus pi added to 0. So we just had pi x left. And then I've subtracted 5x on both sides. So here we're going to get 5x minus 5x is 0 as well. Okay. So over here we have negative 5 minus pi. Over here, well, we can put these together with like terms, and it's a little weird, but we know that normally, like if this was 8, we'd do 8 minus 5 to get 3. In this case, we're just going to do pi minus 5, and we could calculate the decimal, but it's a little easier to just leave it there. And then that equals minus 5 minus pi. And then our final thing here is to divide both sides by the thing multiplying x. And again, like if this was 3x, it would be clear that we would divide both sides by 3. But it's not 3x, it's pi minus 5 times x. So we're going to divide both sides by pi minus 5. So you can see it's a bit more complicated, but it's really the exact same thing that we were doing before, just with numbers that are more complicated. And again, if you put this into a decimal approximation, then it would be easier to see why it works this way. But if we want an exact value, we have to keep it like this. So pi minus 5 divided by itself is 1. All that's left is x. And then over here we have minus 5 minus pi over pi minus 5. And I think that I changed a number when I typed in this example, that I should have used 2 and x minus 1 instead of 5 and x minus 1, because when we put this into our calculator, we get negative, let me put brackets here, negative 5 minus pi divided by brackets pi minus 5, we get 4.38095. So actually it does work out to a positive number. Okay, good. So we got 4.38 approximately. And since we're dealing with, we don't have units here, so it's just going to be 4.38. All right, so that one was probably a little bit confusing. We had to do a lot of different things. We had to set up our diagram so that we could see what was going on. We had to figure out formulas or expressions for the perimeter of the circle and the perimeter of the rectangle involving x. We had to set them equal because we knew that the perimeter of both shapes was the same. And then we had to do distributive property and a bunch of careful solving steps, treating pi like a variable and a number at the same time, kind of. So it's a pretty complicated situation. So I'm going to pause now. Feel free to ask some questions, including like, can you go over that again? Very valid question. All right. I expect that this would be super confusing the first time you see something like it. So please ask questions if you have them. I don't want anyone sitting there going, what did he just do? And this is definitely a complicated question. If you feel like you fully understood it, put a 1 in chat. If not, give me a question. Thank you, Owen and Adam. Thank you, Alan. Thank you, Emma. All right, so I'll keep my eye open for questions. As you can see, pretty complicated here in a lot of ways. So feel free to go back and replay this. When you're going through the quiz, I think you'll quickly realize which question is similar to this one. Feel free to replay this one, take a look through it as you're trying to answer the other question and use it for ideas and for assistance. Okay. On to our third question, and I'll come back to the chat in the moment. So question 3, we want to know what value of m makes the following equation true. So we have 3 times x to the power of 5 times x to the power of 6 all to the power of m equals 3x to the power of 23. Let's move this up. I'm going to be honest, I'm finding it almost unbelievable that there are no questions about the second example there. But that is okay. If there really are none, fantastic. We will keep moving along. But if you do have one, please ask it. I'd much rather that we solve it now than that you get stuck partway through the quiz. Okay. So looking here at the exponents part, we have this m up here in the exponent. We have x's on both sides, and we want this to be equal. So we need to think through our exponent laws. So one thing that's important to remember is even as you're doing fraction math or exponent math or any of these other calculations that we can do with things that aren't just regular numbers, it's important to remember order of operations. So a lot of students here might think, okay, x to the 5 times x to the 6, I'm going to go ahead and add the exponents together because when you multiply 2 powers with the same base, you just add the exponents. That is true, but it doesn't follow order of operations. So here we have a power, an exponent on our power, and then a multiplication. What do we do first? We do the exponent before we do the multiplication. So that means we're going to get 3x to the 5 staying that way, and we're going to need to deal with this part here, x to the 6 all to the power of m first. So let me know in chat, what operation do I do with the 6 and the m, with the two exponents, if I have power of a power? So what operation do I do with the two exponents when I have power of a power like this? All right, it looks like people may be a little stuck. So quick reminder here. We saw early in the course an alternative way to think about order of operations that kind of makes more sense than just it's bedmas. So we said addition is kind of the fundamental operation, basic level, bottom level of the operations. Its opposite is subtraction, and that's why addition and subtraction are together in order of operations. You just do whichever one comes first as you go through left to right. And then repeated addition is multiplication, and the opposite of multiplication is division. And that's why multiplication and division are at the same level in order of operations. You just do whichever one you get to first, left to right. And also why they are both ahead of addition and subtraction, because multiplication is repeated addition. And then if we repeat multiplication, like 3 times 3 times 3 times 3, well, that's 3 to the power of 4. So that is an exponent. And the opposite of exponents are square roots. And later on, not actually till grade 12, you'll find out that there's a third mystery operation out here called the logarithm. We're not going to worry about that one right now. So we have this nice table, and then we have brackets, and they're above the table, because what we really use brackets to do, they're not their own operation. They just let us say that we're going to do another operation first. Okay, so hopefully you remember that from early on. The reason that's useful right now is that if we have an exponent situation, we can always look at what operation is there, and whatever's directly below it in the table is the one we need. So we have x to the 6 all to the power of m. So we have an exponent of a power. If we have an exponent of a power, we're going to look right below it. That's multiplication. We're going to multiply the exponents. So here I'm going to have 6 times m as the correct way to simplify that. And that's going to equal to 3 times x to the 23. And now I have two powers with the same base multiplied. Tell me in chat, if I have two powers with the same base multiplied, what operation do I need to do with the exponents? What operation do I need to do with the 5 and the 6m when I'm multiplying two powers with the same base? Okay, so again, if you're stuck, take a look at what we've got happening over here in the table. I am multiplying two powers with the same base, so I'm using a multiplication. So I need to do what's directly below it with the exponents. So I'm going to add the exponents. That's 5 plus 6m. equals 3x to the 23. All right. So now we can see that we've got pretty similar things going on here. We have the 3 multiplying on both sides. We have the x on both sides. In order for these to be the same, we're going to need 5 plus 6m to equal 23. So let's state that as its own equation. 5 plus 6m has to be the exponent 23. Well, now we just have a regular equation. So go ahead, solve this equation. Once you have an answer, tell me what m equals in chat. Give you about 30 seconds head start, and then I'll start solving it here as well. Once you have an answer, please put it up in the chat. Thanks, Owen. Thank you, Adam. Thank you, Nina. Thanks, Sabrina. All right. So I want to get the m isolated all by itself. So I'm going to subtract 5 from both sides so that 5 minus 5 is 0. All that's left is 6m. On this side, 23 minus 5 is 18. I just want m. I don't want 6m. So I'm going to do the opposite operation, which is to divide. 6 divided by 6 is 1. 1 times m is m. 18 divided by 6 is 3, as many of you are saying in the chat. So there we go. That helps us or shows us a method for figuring out what number has to go here to make both sides of this equal. So hopefully you found that useful and interesting. I'm happy to take questions about any of that. I was expecting a lot more questions for sure. So feel free to ask some questions. Give you about 20 seconds to think about it, and then we'll have one last thing to talk about and then move on. All right. So did the x's just cancel out? That's a great question, Nina. What I did here, I didn't really cancel them out, although I guess you could think of it that way. I just said that for these two sides to be equal, everything else is in place except the exponents, right? The 3 is the same on both. The x is the same on both. So this 5 plus 6m needs to become 23. And if 5 plus 6m needs to be 23, well, that means 5 plus 6m equals 23. So it's not really a canceling as much as a recognizing that the only part of these two that's not the same yet is the 5 plus 6m and the 23. So I can just work on that part separately and calculate it down and figure out what m has to be to make 5 plus 6m into 23. So hopefully that makes sense. Okay, I'll keep an eye for other questions in the chat. Just want to wrap up a couple last things here. So the first one is, if you do have jokes to suggest, feel free to send me an email. I'd be very happy to see some more of those. And the other one is, if you do have YouTube channels about math or science or technology or engineering that you think are interesting, and they don't have to be, they can be applied science or applied math or applied engineering and so on. So if you want to, if you have a good channel about gardening that talks a little bit about the biology of gardening, that's great. If you have one like this do-it-yourself dismantling of old objects, where they talk about the mathematics of electronic motors and so on, those are great too. Please send those my way as well. I'm very happy to check them out. I'm always looking for new YouTube channels to learn from, and happy to share them with the class as well. So that's it for today. If you can just give me a 1 in the chat if you are feeling like you're ready to try out the quiz based on the questions that we just did. And if we get a few 1s there, then we'll close up the stream. Thank you, Sabrina. Thank you, Owen. Thank you, Adam. Thank you, Alan. Thank you, Emma. Thank you, Jordan. And Nina, I see that the explanation makes sense. That's great. All right. Thank you very much, folks. Short stream today. I hope you enjoy the rest of your day. And we will see you again Friday at 1 p.m. Take good care.